I've created a very basic structure for building exterior, which is being generated out of cubes. We'll now look at some of the concepts which we need in order to get this building to work, and we'll begin isolating some of the components of the building. So currently we have a building, and we can create various shapes for this building. This building is very much a Mies van der Rohe building, as everything is very boxy and contains squares and rectangles. We are creating a building which has multiple floors, and there'll be two ways in which these floors can actually manifest. And these are pretty straightforward. We'll have floors which have a normal which faces upwards, and we'll have floors that have normals that face downwards, and usually these will be at the base of the building. However, this is not always the case, and we should be careful of making assumptions based off this. For example, we could have an overhang, which could either be something like a balcony or a walkway, and here this floor would also face downwards. Now this is not necessarily particularly useful, and we will want to have all of our floors in the building be consistent. We will also want them to work with the player, so by default all of the floors should face upwards. This will give us a consistent way of dealing with the floor, and we want the point at which the floor is generated to be well defined, as that will make it easier to combine with other components. And essentially, to give these floors depth, we'll extrude them downwards, and this will mean that the top of the floor should remain consistent, as it should have a height of 3. This consistent height can be used to add items like staircases, because from floor to floor the distance will always be 3, and the base of the floor will always align with the walls of the building at that floor. So essentially one of the things which we will need to do is make the normals of our floors point upwards. However, we have another problem with floors, and that is the majority of the floors are actually not being generated. So for example, in the center of the building here, we will have 2 floors in terms of the height of the building, but we'll only be generating the floor itself for the ground. So this central part of the building will need to have a floor, but is currently not having a floor being generated, and this can cause a number of problems. One of the main issues being that our walkway has a floor, however the main building does not, and these are at the same height. We'll also have a floor at the base of the building, but above this we will have a ceiling. However, for the ceiling we will have a tower, and this tower will also currently be empty and have no floor generated. So we will have a ceiling for the tower, but the interior of the tower will have no floors. So we're going to need to find a way of generating all of the floors so that we have a consistent floor for every building floor. So I'll need to generate all of these floors, and I want all of these floors to have normals which will face upwards. We will, however, need to take into account that there are parts of the buildings which we are already generating, and we'll want to make sure that these do not clash with the geometry which we're going to generate. So we'll need to create the geometry for all the floors, and we'll need to tie all that geometry together. So the reason for doing this is we want the building to have the possibility for an interior. It's always easier to simplify things rather than to make things more complicated, so I'm going to create functional buildings first, and then I'll work on pure facades later if they are needed. So I can now start working on the building, and before we do anything else, we're going to need to separate the parts of this building. I'll need to separate this building into separate floors before we worry about the floors for each floor. So I have a basic building which is being generated from cubes, and this is done using VDBs. We'll need to extract information from this mesh. We'll also need to add information to this mesh, and we'll also want to split this mesh up so that it is more logical. I do, however, want to isolate this branch. This is giving us our basic information, and we may use this in other ways. So I'm going to separate this from the main part of the network, and I'll do this by getting a null. I'll place this null before my output, and I'll call this null base mesh out. So this will isolate my basic mesh. I can then separate my output node, and I'll put this network into a netbox. I can now start the next part of the network, and I'll do this with an object merge node. In this section of the network, I'm going to create some attributes, and I'm going to split up the geometry. The first thing that I want to do is calculate the number of floors that this building has. For this, I'll get an attribute wrangle node. I'm going to store this as a detail attribute, and this will be an integer attribute. I will need to update the object merge node as I currently have no geometry to work with. I'll set my object path, so this will be ../base mesh out. I can then work on the vex script. I want a vector variable which will be the size of our building, and this will have the variable name size. I'm going to get this from the bounding box. This will be done using the getBoxSize method. This method will give us the size of the bounding box as a vector. The argument will be for the geometry, and we'll get this from input 0. I'll then want the number of the floors. I'll store these in a numFloors attribute, and this will be an integer attribute. I'm going to enforce that this is an integer, and I'll get the value of this using the floor function, and I'm going to get this with our size of the building in y. So this will be index 1, and I'll divide this by 3. 3 is the current height of each floor of the building. I'll need to correct my typos. This should be a 1 and not an I. I can then examine these values in the geometry spreadsheet, and we should see that this building has 6 floors. We can double check that this is correct for this building, as we can count the floors here, and we should have 6 floors. So this is correct for the moment, and it should technically be correct. I'm then going to get some group nodes, and I'm going to group the geometry by normal, so I'll activate the keep by normal section. We'll need to make sure that we're keeping primitives, and I'll deactivate the base group section. Here I'm going to select all of the normals which are facing downwards, so the y value of our normal will be -1. I'll give this node a name, and for the moment I'll call this floors. I will set the group name with the node's name, so this will be $OS. I'm then going to get an attribute wrangle node, and I'm going to update the normal vector for the floors. I'm then going to specify this with our group. I'll need to make sure that the group type is primitives, and I'll make sure that we're going to run over primitives. I'll then double check what I'm getting with my group, and currently my group is selecting everything, and that is because I have a spread angle of 180 degrees from the normal. I'll lower this value, and now I'm only selecting the floor. I can then update the normal for the floor. I can return to my attribute wrangle node, and I'll set the group to be my floors. I can then update the normal with @n times equal -1. I'll test this, but this is not working the way I want it to. So I'll do this the more straightforward way. I'll get a reverse node, and in the reverse node I'll specify the floor group. I'm then going to get a group node again, and once again I'm going to be creating the group using primitives. I'll be grouping these by normals, and in this case the normals are going to be facing upwards. I'll lower the spread angle, and if I take a look at the group, it should now contain all of the floor surfaces for the building, and this will work for both the floors and the ceilings. I'll give this group a group name of floors and ceilings. These names are horrible, but they will work for the moment. I can always rename these later. Following this group node, I'm going to get a group delete node, and I'm going to delete the floors group. I used this group for flipping the normals, but the floors now are all part of the floors and ceiling group, so I no longer need this extra group. It also allows me to get rid of the ambiguous group name. After this, I'm going to separate my building into components. So I'm going to want to have the walls as one part, and I'm going to deal with the floors as a separate part. So I'll get a blast node, and I'll blast my floors and ceiling group, and I'll make sure that I'm running over primitives. And this will give me the exterior walls of the building. I can now group these exterior walls based off the individual floors of the building. I'll do this in a for each primitive loop. So this will mean we're looping over each primitive individually. I can then get an attribute wrangle node. I'm going to be grouping these buildings by height. So I'm going to be generating a number of groups, and each of these groups will need their own name. So before we create the group, we'll need to create the name. I'll store this in a string variable, and this variable will be name, and this will be created using a sprintf function. The structure of the name of the group will be floor, followed by a wildcard, and this will be %s, and this will represent a string wildcard. We're then going to need something to set this wildcard with, and this should represent the number of the floor which we're on. So I'll need to identify where this primitive actually is, and for this I'm going to calculate the center of each primitive. This will be stored in a vector. We are working over primitives, so we'll need to loop over primitives. Although I should note that we should actually only ever have a single primitive here. The variable name for this vector will be center, and this will be set with the getBoxCenter function, which will get the center of the bounding box of this primitive. I'll get my geometry from the first input, which is input 0. This information can now be used to calculate the specific floor of this primitive. I'll create a float variable, and this will be called floor, and I'm going to calculate this using a floor function. which will round this down to the lowest value. I'll be calculating the floor of the y-axis of our center value. So the index here will be 1, and I'll divide this by 3, as our floor height is 3. This variable actually shouldn't be a float, it should be an integer. I will also want to make sure that we cast our value as an integer, so that this is set correctly. The second argument of our string name can now be set, and this will be floor. I'm now going to add this primitive to a group, and I'll do this using the setPrimGroup function. We'll get our geometry from input 0. We'll then have the group's name, which will be set with the name. The primitive will be the current primitive, which will be at primnum. Because of the for loop, we should only be looping over individual primitives, so there shouldn't actually be more than one primitive. I want to make sure that I'm adding this to the group. We do not want to overwrite the group. We do not want to have a single primitive. We want every single primitive on the floor to be added to a specific group. So the final argument will be 1. I can activate the output. I will also activate the visualizations for the groups. We'll be looking at the primitive groups, and there should now be several groups which have the name floor followed by a number, which means that all of our walls are assigned based on which floor they're on. So now we've got our basic setup for our floors. We've also stored our floors and ceilings. Next we can start to calculate the interior floors so that we can group our floors and ceilings more accurately.